Hello everyone. In this video, we are going to discuss about the naive Bayes algorithm. So let's get started. So naive Bayes is a probabilistic algorithm based on Bayes theorem, which is used for classification tasks. So we first need to discuss what the Bayes theorem is. So the Bayes theorem's formula can be calculated like this. That means the posterior probability is equal to likelihood into prior probability and marginal probability. In the naive Bayes, how we can understand this? First, we discuss what does these terms means, as well as we take an example. For example, we have X, that is a set of all the predictor variables, and a set Y, that is the set of response values which can take Y1, Y2 and Y3 values. So with the help of naive Bayes, we are here actually trying to find that how likely a particular value of y is most likely to occur for a set of values for x. For example, the set of x has two predictors x1 and x2, and y has y1, y2 and y3. Okay, so we are trying to calculate for all the possible values of y the posterior probability. That means how likely it is to occur in our data set given that we have some particular combination of values for x. So what is the prior probability here? It is the knowledge we already have. That means the previous probability of any kind of value, that can be y1 or y2 or y3. Now the likelihood here represents how the data behave when we are applying the particular value of y. That means it can be y1 or y2. Suppose say we are going to calculate it for y2. So how the data behave with respect to the value y2. Then we have marginal probability, which is how data behave overall. That means we are not using or calculating the probability with respect to any kind of y value, but we are calculating the overall probability and overall behavior of our data set. Then we can get, by calculating all these in this formula, we can get the posterior probability of a particular value of y. That is the updated information about our particular variable's likelihood. Now there can be some types of naive Bayes algorithms, that is Gaussian naive Bayes, multinomial naive Bayes or Bernoulli naive Bayes. So Gaussian naive Bayes is used when we are applying the classification for normal distribution. Multinomial is suitable for discrete classification data, and Bernoulli is applied on binary features. Now we are going to see the code here. I have imported the necessary libraries, that is pandas, and from model selection the train test split, which is used to split the data into test and training data set, and from sklearn we have a naive Bayes module from where we can import the Gaussian NB or multinomial NB or Bernoulli NB as well. But here I am going to use the multinomial NB as I am applying it for a classification task. Now first I will run this, then we are going to read the data here. This is a shopping trends data set that we have read in here. Now here we have taken the data, that is predictor variables, into x, and the target variable we are trying to predict from y. Now we are going to convert it into one-hot encoding because the algorithm needs the data converted into a binary format to work properly. So we first converted it using the pd.getDummies, which is a function in pandas. Now we are going to split the data set into training and test data set using the x and y. X has the data from gender, location, season and item purchased column, and y has the data of the category. Now we are going to train the model. So first I called the model multinomial NB into a object, that is model, and fitted the data, that is x train data and y train data, and then we are going to make the predictions. If we want to see how accurate this model is working, we can run this code and see that the accuracy is 0.97, which is a good one. So that means our model is predicting correctly. So this is how a multinomial NB, that is name base, works. So that's all for this video. Thank you.